guys, happy new year. Once again, happy new year to you all. This is Daniel Mas Tutor. So I will really be happy if you subscribe and if you subscribe and like my video, watch my video, follow for more. Today we'll be dealing on the topic real numbers. Real numbers. We'll be dealing on the topic what? Real numbers. Now, the question here comes here, what are real numbers? Real number, the symbol of a real number. So a real number, the symbol of a real number. I symbol is what? Called real numbers. So what are real numbers? Real number are those numbers. Every number on the number line. Every real number. All real number is called a real number. Like counting numbers. Let me say counting numbers. Counting numbers like from positive to negative number, minus 1 plus 1, all these are real numbers. We call them real numbers. So what that is in points, we can say, if we say now this is the number line, this is negative infinity, this is positive infinity. Now, this is it. Here is 0. This is the what? All these points are called real number. Now from here to here, there's what? There are values here. To say, you see 1 over 2, 0.5. You see it here, 0, you see 0.5 here. So you have 0.5, 0.6, 0.7, all these numbers on the line are called real numbers. So these are what? Real numbers. Then now, we have real numbers properties. Real numbers property. So this, remember, positive infinity, negative infinity. There is all the numbers, they are called real lines. All the numbers are called real lines. Then everything together is called what? A real number. Now talk about now. We have real numbers properties. The properties of a real number. We have the algebraic property. We have the order property. We have the completeness property. I say it again. We have the algebraic properties. We have the order properties. We have the completeness properties. Now, for the algebraic properties, see these properties affirm that real numbers are amenable to arithmetic, operation, addition, subtraction, multiplication, and division. What does this mean? It means that if you add two real numbers together, you get another real number. If you multiply two real numbers together, you get another real number. If you subtract two real numbers, you get another real number. For example, we have 2 minus 2 is equal to what? 0. 0 is what? A real number. 3 minus 2 is equal to what? 1. 1 is a what? A real number. 2 times 2 is what? 4. 4 is what? A real number. When you add, subtract, and multiply, you also get a real number. That's called the algebraic property. They follow the what? The algebraic procedure. Your addition, your subtraction, your multiplication, and your division. Then now, the order property. You see what? This property pertains to the arrangement and sequence of real number arranged on a real line. For instance, I give you a real number A and B. Now, you can see this order property. You say what? Let me come again. See, this property pertains to the arrangement and sequence of real numbers arranged on a real line. This thing, they pertain, they have a pattern that they follow, and what? They are being arranged on a real line. They don't just move. Which is real number, the other property, they are being ordered. You can't see 1 and you see minus 1 here. No. This is positive. All these side is what? Positive. All these side are what? Negative. So that's when they say they are being arranged on a number, on a real line. Now, we can say now, the inequality relation, A is greater than now. Let's look at it for the order. You can see that if we bring something, now this order follow the multiplication, the addition, the division, and it follow the laws. No matter how you add it, no matter whatever you do, this thing they will always align, they will always follow order. They will always follow order. Now, you say n, if you say m is less than n. Now, whatever value you add to these two, you want to check whether this thing is in order. You say what? You say 1, no matter whatever you add to these numbers, they will never change. They will always follow order. Now look at this. Something like this. Whatever value you add to both sides, let's say m is equal to 3 is less than 6. Now, if 3 is less than 6, let's add 2 to both sides, whether the case will be different. Here is plus 2. 2 plus 2. Here will now be 5. It's less than 8. You can see, no matter what you add to it, the equation will still remain the same. It must follow order. You can't solve it because you add 5 to here, you add 5 to here, say, because of 5 is added to here, say, this particular one is not greater than, it's not lesser than this or the other one this way. Never, not possible that way. So, on other property, 5 is less than 8. No matter value you add to it, 5 will always be less than 8. That will say m is less than n. If I add plus 2, 2 plus m, this is still also less than what? Less than this. Because 2 plus m is less than n plus 2. That is what the order must follow. Take m to be 3, put your 2. Take m to be 6, put it there. The order must follow. No matter value you add to it, the order will still remain. Also go to what? When you do your when you add. Now if you say, like what we did this call for addition, what about subtraction? You now say n is less than n, because a p minus n and n minus p. No matter value you add to this will still be less than this. No matter the value you add to it, this will. Now let's do this way. We say now, imagine your theory. So 2 is less than 4. Okay. Now, let's add no, 2 is less than 3. Let's add 4 to both sides. Here will now be 2 minus 4 is less than 3 minus 4. 2 minus 4 gives us what? Minus 2 is less than what? 1. I seen it. 2 is less than 3. Then 2 minus, add 4 to both sides. 2 minus 4 is less than 3 minus what? 4. 2 minus 4 will give us minus 2. Then 3 minus 4 will give us 1. Minus 2 is less than 1. Okay. 2 minus 4 gives us minus 2. 3 minus 4 gives us minus 1. Minus 3 is always less than minus 1, which is minus 1 is greater than minus 2. That's called the order property. These things, they follow what? They follow order. Now, if we say, okay, let's move on to the multiplication aspect of it. The multiplication aspect of this is minus 4 is less than it's less than 3. Now, let's multiply. Minus 4 times 2 is less than 3 times 2. You can see it. Here we go minus 6 is less than what? 6. No matter what you add. Sorry, 4 times 2 gives us what? Minus 8. Sorry for that mistake. 4 times 2 gives us what? Minus 8 is less than what? 6. Now, whatever value you are going to add to both sides, this order way must be less according to what is here, the order property. This have been put in order. Then the last but not least, say the completeness property. See this property, I said that every point on the line, on the real line, corresponds to a real number, implying the real line is devoid of holes and gaps. It is continuous. What does that mean? Is that on this real line, there is no hole. There is no gap. No single gap. From here to here, there is no gap here. It is continuous. There is number at every point of the line. At every point of the line, there is a number on a real line. At every point, there is number on it. At every point there is no hole on it. So now move over to subset of the set of real numbers. What are the subset of real numbers? Subset of real numbers. Now I've talked about the properties. Now I want to talk about the subset of real numbers. How many types of real numbers? Because it's also called subsets. It's also called types. Types of real numbers. Whereby we have the natural numbers. Under real numbers, we have the natural. We have real numbers. That's a subset of the set of real numbers. We have the natural numbers. Natural numbers. What are these natural? These natural numbers is denoted as what? As n. Natural number is denoted as what? As n. Capital letter n. And these are numbers that are what? These are positive counting numbers. They are positive counting numbers. And you can say 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive to positive infinity. These are what? Natural numbers. Now, one special form of natural number is the prime numbers. So, one special form of the natural numbers is the prime numbers. The prime number is also a part of what? The natural numbers. Then we'll now move on from there to integers. Integer is denoted as what? As z. Integers is denoted as what? As z. These numbers, these are negative numbers. Negative numbers. Integer, they are negative, 0 and positive. Integers, we have the both positive and negative integer, and it's denoted like this: plus or minus. Plus or minus. You see, integers are both positive and negative, and that's what we call. Remember, take notes. Now take note of something, that all prime numbers are natural numbers and all natural numbers are integers. But not all integers are what? Are natural numbers. All prime numbers are natural numbers, all natural numbers are integer, because integer cover both positive and negative aspect of it. They will now move on from there to rational number. Rational number is denoted as what? As q. Rational number is denoted as what? As q. What are rational numbers? See, these are numbers that can be expressed in the form of integers. The form of a over b, where b is not equals to 0. These are numbers that you can express in the form of quotient of two integers. Where b is not equals to 0. These are what? Rational numbers. Then what about irrational numbers? Irrational numbers, these are numbers that are what? Represented what? In square root, log, pi. All these are what? Irrational numbers. Listen, these are what? Irrational numbers. Then from there, I think I'm going to move to some example of rational numbers. We have some example given to us here that we will solve. Okay, now these are some examples. Now, say convert the numbers b equals to 0.125 to irrational number, which is to put it an irrational number. Like I said, irrational number what? Number that can be expressed in a over b, where b is not equals to what? 0. That's why she put it there. She put this number in this form. Now, solution. Question 1. Now, b is equals to 0.125. can we move this? How can we convert? First of all, in mathematics, when we are dealing with decimal points, remember, if you have something like 0.2, if you move it once, it means 2/10. So anytime you move, if you have 0.333, 1, 2, 3, 1, 2, 3, then the top will be 3, 3, 3. So if the point should move like 4 times, you add that number over what? Over 4. Now, that is first method, but the reason I want to use this other method, so that because there are some, like this your college decimal, we can't use that method to do it. We can't just put points there, put everything on to work that you get the answer right. Or maybe this equation, we get the answer right. So we're going to use another method to do it. Now this method, this is how it goes, this is how it goes. So now, this is 0.125. B is equal to 0.125. Now, this is how it's going to go. It's going to move 1, 2, 3. Our answer will be, which is equal to 10 raised to the power of 3. As it's moving this side, we are adding it to this B. As it's moving this side, we are taking this thing, we'll add it to this B. It will now be 10 raised to the power of 3B equals to 1, 2, 5. There's a sequence, there's the reason why I said we should use this method. Now, for me now, can I say, okay, 10 to the power, which is 1000, right? Is equal to 1, 2, 5. Your B divided by what? 1000 divided by 1000. Our answer now be B